So I'm going to be doing another application question for differential equations, and this is a half-life problem. These are pretty common. This is the growth and decay formula, and this is common to address problems like this. So let's get into it. So we know that the half-life of cobalt, it says, what we're told is the half-life of cobalt is 5.27 years. Right now the level is 100 times what it should be. When will it be okay? Now, two things we're told right off the bat. That the half-life of cobalt is 5.27 years. Now that's enough to find out what K is. And the way we do it is we know it's a half-life, so we sub in half over here. And then we know initially we start with one whole because it turns into half, right? So we start with one whole. So our initial value is just 1. And then we have e to the k times 5.27 because that's how long it takes for one whole cobalt to hit a half-life of hit the half-life. So we have the equation set up, right? This is just a simplified version. I took the 1 out because obviously you don't need to write it. And here it's very simple. We just take the natural log of the left side and it removes the k from the right side. That way we're left with k times 5.27, right? It removes the k and we just have this nice, easy to solve formula. All we got to do here now is just divide both sides by 5.27, and we're left with the variable k. We found out what it is, and it's roughly about 0.131. That's a 3. 0.131. Now, the question asks, right now the level is 100 times what it should be. When will it be okay? So now we know what k is. Now we could plug it into the general formula, which was this. Now let's just set up the general formula first. We know that k is true for all formulas regarding this problem because it's a constant. So we can just plug it in again. So we have this set up, the same equation, but now we have a k. We don't have a time. That's what we're looking for. When will it be okay? We're looking for the time. So now we want to know how long will it take the level that is initially right now, right? It says right now the level is 100 times what it should be. So initially it's at 100. Right now we're at 100. We want to know when it's going to get to 1 or 1 whole. When will the level be okay? So that's how we're going to set up the problem. We have our goal, which is 1, and we're starting off with 100. Right now it's at 100. Now we just got to look for time. Now that's pretty easy given what we just did. You just have to do it again, but a little differently. We divide both sides by 100. 1 over 100 is equal to e to the 0.131 times t. I'm sorry, that's a 3 again. You take the logarithm of 1 over 100 and it removes the e. Now we're left with this nice solvable, easy to solve equation. You divide both sides by 0.131 and you solve it and we get t. So it'll take 35 years roughly for this entire thing. If it was at 100, it starts with the levels are 100 times what it should be, and for it to get to 1 or get back to normal, it's going to take 35 years. So we just solved that.